So this is 2014 sample paper, it's paper 2, question 9. A regular tetrahedron has 4 faces, each of which is an equilateral triangle. A wooden puzzle consists of several pieces that can be assembled to make a regular tetrahedron. The manufacturer wants to package the assembled tetrahedron in a clear cylindrical container with one face flat against the bottom. If the length of one edge of the tetrahedron is 2a, show that the volume of the smallest possible cylindrical container is 8 by the square root of 6 over 9 pi a cubed. So the first thing that we're going to note is if we're looking for the volume of a cylinder, we need to just make a note of the formula that we need. So pi r squared h. So they want us to express the volume in terms of a, so that means we need to find something for the radius and something for the height. So in terms of a, they've given us the length of sides of the triangles as 2a. The first dimension that I'm going to find is the radius. So this is going from the center of the triangle out to one of the vertices. So I'm going to just draw a sketch to simplify what we need to do. This is really handy, especially when we have a 3D shape, but we need to deal with a 2D shape, so the triangle, in order to find one of the dimensions. So this is going to represent any of the triangles really, but the one at the bottom. I want to find the radius, marked with 4. Because it's an equilateral triangle, I therefore know that I have A, and I also know that this angle here is equal to 30. There's a few different ways of finding or in terms of A. Could use sine rule and other things, but because I have the cone graph and the table, I'm going to use the cosine of 30. So the cosine of 30 is equal to A over r. So r multiplied by the cosine of 30 is equal to A. So r is going to be equal to A divided by the cosine of 30. So cosine of 30 is square root of 3 over 2. So when I simplify, I'm going to find that r is equal to 2a over the square root of 3. So now I need to find something for the height. So the height of the tetrahedron is equal to the height of the cylinder. So we now have something for r. We know that the slanted side is 2a. So we're going to use Pythagoras theorem in order to find something for h. So again, I'm just going to use another sketch. Just kind of taking out what I need. So we have the radius is 2a over the square root of 3. We have the slanted side is 2a, and we're looking for something for h. Make sure that we use brackets so that we don't make the mistake of just writing 2a squared and forgetting that it should be 4a squared. So now we're just simplifying and then expressing it in terms h in terms of a. So I've just simplified h to be 2 times the square root of 2a squared all over the square root of 3. You could leave it as just the square root of 8a squared over 3. So we have something for r, we have something for h. So we're going to fill the two of these into the formula for the volume of the cylinder. So we have pi 2a over the square root of 3 squared multiplied by h. So when we simplify, we have a squared, it should just be a, So a squared multiplied by a, we're going to get a cubed. Pi. 4 by 2 is going to give us 8. Square root of 2. All over 3 times the square root of 3. When we put 8 times the square root of 2 over 3 times the square root of 3, it's going to simplify to give us exactly what they've asked us for, which is 8 times the square root of 6 over 9. So just to recap, first of all, taking the triangle at the bottom to find the radius of the cylinder by finding the length from the midpoint out to one of the vertices using the cosine of 30, a and or. So we express or in terms of a. Then taking the right angle or the right angle triangle in order to find h, the height of the cylinder. Again, simplifying so that we have h in terms of a. Just make a little note that I made one error in that we kind of spotted, and finding the square root of all of that, it means that a squared just here should have been a and not a squared as I have written it. So we have or and h in terms of a. We substitute them into the formula for the volume of the cylinder and we simplify to find exactly what they've asked us.